Section 14.3, verify trig identities. This is where trig meets geometry meets algebra. It's so fun, all of it all at once. Okay, I've really quickly, and you can probably tell because it's scribbled, I've really quickly shown you the identities that you already know. You've already dealt with the reciprocal identities. You know cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. You also already know the tangent and cotangent identities. You know that tangent is sine over cosine, and you know that cotangent is cosine over sine, all right? These you know, you should be familiar with, you should recognize. Let me give you some new ones. All right. So these identities are going to be useful for our puzzles. This will be so fun. Okay, the Pythagorean identities say that the sine squared of theta plus the cosine squared of theta equals 1. And that has to do with Pythagorean theorem. And if you want to derive it all, we can do that in class. If you want to just trust me that these are true, we can do that too. All right, 1 plus the tangent squared equals the secant squared. 1 plus the cotangent squared equals the cosecant squared. The cofunction identities say that the sine of pi over 2 minus theta equals the cosine of theta. Cosine of pi over 2 minus theta equals the sine of theta. Tangent of pi over 2 minus theta equals the cotangent of theta. And the negative angle identities, check this out. The sine of a negative theta equals negative sine of theta. The tangent of negative theta equals negative sine of theta, but the cosine of negative theta equals cosine of theta. And that freaked me out, and I had to look it up to make sure that the book wasn't lying to us, and it's not. If you'll look at the functions, at the graphs that we did in the last section or two, the cosine, remember, the cosine graph is symmetrical about that y-axis. So wherever your theta is on the right-hand side, on the positive side, it's going to be exactly the same on the left-hand side, okay? So that's why cosine of negative theta equals cosine of theta, all right? Now, I give all of you these as pieces to puzzles that we're going to use, we're going to work. Now, what we've done in the past, what I want you to do is I want you to use the identities. So the directions for this set are use the identities to find all of the other trig functions if I give you sine of theta equals 4 over 5. Now, in the past, what you've done is you've drawn the picture and you've put theta in and you've used Pythagorean theorem and you've worked them out this way. I want you to use your identities that you know. So what we're going to do is this. We're going to say we have to use our Pythagorean identity here, and whoa, there it is, Pythagorean identity, and we're going to say, well, sine squared of theta plus cosine squared of theta is going to equal 1. And we have sine of theta is 4/5. So 4/5 squared, and that's not an 8, that is a 5, plus cosine squared of theta equals 1. All right, are you with me? This is so fun. Okay, so now what we're going to do is let's get the cosine by itself, cosine squared, so we're going to subtract the 4/5 squared from both sides. So cosine squared of theta equals 1 minus 4/5 squared. Now, if you take 4/5 squared, you get 16 over 25, and if you take 1 minus 16 over 25, you have 9/25 left. All right, did you follow all that? If you need to pause and catch up, that's fine. I was able to do it before I turned the video on. Ha! All right, so now cosine squared of theta equals 9 over 25. So now all you have to do is take the square root of both sides. So cosine of theta equals plus or minus 3 over 25, or 3 over 5, not 25, 3 over 5. And we happen to know that we want to be between pi over 2 and pi, which is the quadrant 2. Oh, not a theta 2, quadrant 2. And in quadrant 2, we happen to know that the cosine is negative. So we want cosine of theta is going to be negative 3/5. All right? So cosine of theta now is negative 3/5. And now we can figure out all of the other pieces from that. Because we know tangent from our identities, and once again, we're using the identities. You don't have to draw the picture. The tangent is going to be sine over cosine. So we're going to have 4/5 over negative 3/5. So when we flip and multiply, negative 5 over 3, the 5's reduce, and we have negative 4/3 is our tangent. Cosecant is 1 over the sine, and if you take 1 over a fraction, it simply flips it. So that's going to be 5 over 4. Secant is 1 over the cosine, and if you take 1 over anything, it simply flips it. So that's going to be negative 5 over 3. Cotangent is 1 over the tangent, and if you take 1 over a fraction, it simply flips it. So cotangent is going to be negative 3 over 4. Ta-da! Simple and easy, and we didn't have to draw a little triangle. All right. So, and I think that should be quick and easy. Let's continue on. If I want you to simplify, let's use the identities, and I want you to simplify tangent of negative theta times cosine of theta, and I want to get that just simplified. It seems kind of long and laborious. Let's see if it can simplify down. Well, we know from our negative angle identity that the tangent of a negative theta is negative tangent of theta. All right? So negative tangent of theta times cosine of theta looks like this. And now we also know that tangent, we know from our tangent identities, tangent is sine over cosine. So now we have negative sine theta over cosine of theta times cosine of theta, and this would be the same as cosine of theta over 1. And if you're multiplying across, the cosine and the cosine will reduce, right? You got one on top and one on bottom, you can reduce. And so if we simplify this, we can get negative sine of theta, and that is much simpler than all of that. Pretty cool, huh? Okay, let's do another one. Let's simplify sine of theta plus cosine of theta times cotangent of theta. Whew, okay. Well, let's see. We know, what do we know? Sine is just sine, cosine is just cosine. Oh, but cotangent, remember, is cosine over sine. Let's see if that gets us anywhere. So we've got sine of theta plus cosine of theta times cotangent is going to be cosine of theta over sine of theta. Okay. Well, that's fine and dandy. We can't add these unless we have like denominators. So let's multiply. Let's get a like denominator of sine over theta. So let's multiply this by sine over theta, sine of theta over sine of theta. See what I'm doing? Just kind of manipulating everything to get it to look like what I want it to look like. So now, sine times sine, we've got sine squared of theta over sine of theta plus cosine squared of theta over sine of theta. And now let's just combine that because they have the same denominator. That's the same as sine squared of theta plus cosine squared of theta over sine of theta. Do you see where I'm going? Now we've got sine squared of theta plus cosine squared of theta, and if you'll remember, that is one of our Pythagorean identities. Sine squared plus cosine squared equals 1. So this equals 1, all of this equals 1 over sine of theta. And 1 over sine of theta, remember from these, from the reciprocal, 1 over sine is just cosecant. So all of that just equals cosecant of theta, and that is our simplified answer. I love this stuff. This is so fun. Okay, now, so that's just two of the same type of thing. I'll ask you to simplify. Take what I give you and simplify it. Crunch it down. Use those identities to manipulate things around and make it as simple as possible. All right? Then I'll have another set of problems that say verify this identity. What that means is this. And this is kind of where geometry plays a part, okay? Because you got to prove something. All right, here's how we're going to prove it. What we're going to do is I'm going to give you an equation. I'm going to say secant of theta minus cosine of theta equals sine of theta times tangent of theta. Now, if I want to prove this, if this is an equation and I want to prove it, what we're going to do is simply manipulate the left-hand side until it matches the right-hand side. So don't mess with the right-hand side at all. That's what you want to end up with. So take your left-hand side and look to see, what can I use with my identities to manipulate this to make it equal to that? You can't change the value of it. You can't add or subtract anything to it, but you can use those identities to manipulate what it looks like so that it looks like this. So use your identities. You know secant is the reciprocal of cosine, right? So secant is 1 over cosine of theta minus cosine of theta. And if we're going to subtract those, we need to have like denominators. Why am I all of a sudden secant is, let me make sure. Did I mess up? Okay. We need to have like denominators. Yeah, that's right. Okay. We need to have like denominators. So we're going to take cosine secant minus, why am I all of a sudden, it's because I'm looking at the wrong one. Okay. So we're going to take cosine of, we've got to have cosine squared because what we want to do is multiply by cosine over cosine. All right, so then this becomes, let's go this way for now because I don't have a lot of space. So now we have 1 minus cosine squared of theta over cosine of theta. And let's look to see this 1 minus cosine squared, was that something? 1 minus cosine squared. Uh-oh, it's not. What have I done? Oh man, I hate this when this happens. Sine, I'm looking at the wrong one on my, I have notes and I'm looking at the wrong notes. Secant, yeah, I'm doing it right. I was just looking at the wrong one over here. Okay, so 1 minus cos, oh, that's why. Check this out. That's why I'm confused. Check this out. Sine squared theta plus cosine squared of theta equals 1. So if you subtract this cosine squared from both sides, then that equals sine squared of theta. Ha ha ha. That's why I was confused, because I was like, oh, wait a minute, it's not up here. But it is if you manipulate this identity, if you subtract the cosine squared. So 1 minus cosine squared of theta equals sine squared of theta over cosine of theta. All right, did I confuse you enough? All right, I also don't have room to, I prefer to see it going down and I'm having to go across. So hopefully you can see this equals this equals this. So now sine squared of theta over cosine of theta still doesn't equal exactly this, but check this out. You can take sine squared of theta and say that that equals sine theta times sine of theta. And that's still over cosine of theta. You see where we're going? So now if you split this up, you can say sine of theta times sine of theta over cosine of theta, and this equals tangent. So now sine of theta times tangent of theta is our identity. Pretty fun, huh? Okay? So the trick is just to manipulate and change what you've got using what you know about those identities to get it to look like what you want it to look like. I've got one more like that. One more identity. Let's see what I've got. I've got sine of theta times tangent of theta plus cotangent of theta. And I want that to equal secant. All right. So now, first what you're going to need to do is you're going to need to distribute that through, right? You need to distribute through. And in the same step, what I'm going to do is I'm going to use my identity and change that tangent. So I'm going to take sine of theta times sine of theta over cosine of theta. All right, do you see that's sine times tangent? Plus sine of theta times, we're going to take it times cotangent, and so we're going to say cosine of theta over sine of theta. Okay, so now we've got sine squared over cosine of theta plus sine theta cosine of theta over sine of theta. But what we can do here is we can reduce, and actually what we'll do is let's reduce that in this step because sine and sine will reduce out, and so we just have cosine of theta here. And now we're adding, so we can't reduce those. We're adding, and we need to add, and so in order to add, we need like denominators. So let's multiply this side by cosine over cosine. Okay, so we can multiply this by a fraction that's itself because a number over itself, because that's equal to 1, and we haven't changed anything. So now we still have sine squared of theta over cosine of theta plus cosine squared of theta. Now you're seeing something, aren't you? So this, when we put it all over, sine squared of theta plus cosine squared of theta all over cosine of theta, this sine squared of theta plus cosine squared of theta equals just 1. So now we have 1 over cosine of theta, and 1 over cosine is the secant. And now we have proved the identity. All right, so when we simplify, we're just starting with this and we go as simple as we can until we've got it into its simplest form. If we're verifying an identity, then what we're doing is we have a goal. We're trying to match up to that goal. So it's kind of the same process, but it's a different, and we end up with the same outcome, but it's a different goal. One is we don't have something we're shooting for, and the other is we have something that we're aiming toward. All right, good luck. Have fun with that.